Good morning, dear students. Today we are going to learn about the most important topic in engineering chemistry, that is, even in applied chemistry, that is, unit number 2, electrochemistry. So, let us have the concept of electrochemistry. First, electrochemistry is the study of chemical applications, and it deals with the interaction of electrical energy and chemical energy. And these type of interactions are basically two important categories. Number one, the process of conversion of electrical energy into chemical energy, and the second important type is interaction is the conversion of chemical energy into electrical energy. That means electrochemistry is the study of the process of interconnect conversion of chemical energy into electrical energy and vice versa through a very important chemical reaction, and this is electrochemistry. So what are electrical conductors? Let us start with some basic points. Number one, what is an electrical conductor? Substances which allows electric current to pass through them are called as conductors or else electrical conductors. For example, all type of metals, graphite, fused salts, aqueous solutions of acids, bases and salts. And there are two types of conductors: electronic conductors and electrolytic conductors. So electronic and electrolytic conductors are the two types of conductors. Let us go to the electronic and electrolytic conductors. So you see the electrode differences between the metallic and electrolytic conductors. Metallic conductors are also called electronic conductors, and electrolytic conductors are the very important second important category. So let us have the main important points related to metallic and electrolytic conductors. Metallic conductors are the conductors in which the conductance is due to the flow of electrons, whereas electrolytic conductors, here the conductance is due to the movement of the ions, mainly due to the movement of the ions in a solution. So next point, in case of metallic conductors, it does not result any chemical change, whereas electrolytic conductors, there is a chemical reaction that is taking place at its electrodes, hence there is a chemical change that is involved. And here in the case of metallic conductors, metallic conduction decreases with increasing in temperature. On the other side, electrolytic conductors, the conduction increases with increasing in its temperature. And the next point in metallic conductor is it does not involve any kind of transfer of matter that is taking place. And in the case of electrolytic conductors, it involves the transfer of matter. These are the main important differences between the electronic conductors and electrolytic conductors, or else metallic conductors and electrolytic conductors. After this, we have the next important category, that is insulators or non-conductors. What are these insulators? Means the substances which does not allows electric current through it. So these are known as insulators. For example, rubber, paper, dry wood, etc. And you see, insulators which does not allows current to pass through them, so therefore they are the bad conductors of electricity. and even glass material is also considered as a insulator. And coming to the next important aspect, that is semiconductor. A semiconductor, actually it is defined as a substance which partially allows electric current to pass through it, and hence the conductivity is not too high or else not too low. So this is a moderate conductivity or electricity. So for example, say silicon, germanium are the best examples of the semiconductors. So after this we have the next important concept that we have to learn, that is related to the electromotive force. What is electromotive force or EMF? Electromotive force or EMF is the difference of potential which causes the current to flow between from an electrode at high potential to one of low potential value. So the current flows between the two electrodes, one with high electrode potential and the one with low electrode potential. That is known as electromotive force, and in turn it is referred to as EMF. Therefore, EMF or electromotive force is given by the equation E cell is equals to E right hand side electrode minus E left hand side electrode. So here E cell refers to EMF of the cell, E right refers to the reduction potential of right hand side electrode, E left refers to reduction potential of left hand side electrode. And we will get a doubt, what is an electrode potential and what is this reduction potential? We have small doubt. So let us go for this electrode potential. What is electrode potential means? It is the potential that is developed at the surface of an electrode due to either loss or gain of electrons, and this is called electrode potential. And the electrode potential is either oxidation potential or else reduction potential. Oxidation potential is the potential which is developed because of the oxidation of chemical reaction or oxidation of the metal by the loss of electrons, whereas reduction potential is the potential that is developed due to the reduction process or due to the gaining of electrons at the surface of an electrode. So for example, if a metal which undergoes oxidation very easily, then it will have higher oxidation potential, and the one which undergoes reduction very easily, it will have high reduction potential. Okay, so this is related to oxidation potential and reduction potential. So let us have some of the important applications of the EMF measurement. How can we measure the EMF? It is by using a experimental determination. We will learn about this in the next slide. So let us have the applications of EMF measurement. Number 1, potentiometric titrations can be carried out. Number 2, transport number of ions can be determined. Number 3, pH can be measured. And 4, hydrolysis constant can be determined. And finally, number 5, the solubility of sparingly soluble salts can be found by EMF. So let us have the next important one, how to measure the EMF. So in order to measure EMF, we have a very important method that is called measurement of EMF by means of potentiometer or potentiometric method by using a potentiometer. So in this measurement of EMF experiment, first there is a circuit in which a long wire AB, which is attached on its either side to a plug key, and next it is attached to the resistance and along with a battery, and on the other side of the long wire it is connected to the positive terminal of the battery, and for example say B side of the wire is attached to positive terminal of the battery, then A side is attached to the negative terminal of the battery, and at the same time in between we have the connection of resistance as well as a plug key is also there in order to switch on and switch off the the circuit. Next, the wire is long wire AB is connected to the a cell of known EMF, that is standard EMF, and the other cell of unknown EMF, which is sample, that is to be determined. Now first we will connect this long wire to the a cell of standard EMF, and which is further connected to galvanometer, and which is connected to the potentiometric wire. Now the potentiometric wire, which is in connection to the galvanometer, so which is now placed on the top of the long wire called AB. On some places of AB it will show some deflection in the galvanometer because it will produce some amount of voltage or EMF. So here, because of the potential that is level up, there will be some deflection in the galvanometer. So after keeping this potentiometric wire on the surface of the long wire AB at certain points, we will find at a particular point there will be no deflection, and it will be exactly zero deflection is observed in the galvanometer, and this deflection refers to null point deflection. So there is a point where there is no deflection takes place in the galvanometer on the long wire called AB. By keeping the potentiometric wire is in contact with the long wire AB, then that point where there is no deflection observed is called as null point. So therefore, once we got null point, then we will stop the experiment, we'll note down the distance and we'll put it as D. We'll mark it as D. And next we will detach the standard cell with a known EMF, and we will connect now an unknown cell which we need to find it out the EMF. Now the unknown cell which is connected, for example say some unknown EMF containing cell which is connected to the long wire on one side, like on the A side, and it is in turn connected to galvanometer, and galvanometer is connected with a potentiometric wire. Again we will repeat the same experiment, like first the potentiometric wire is in contact with the surface of the long wire called AB, then at certain points it will show a deflection in the galvanometer, and after that at certain points, at certain regions or particularly there will be a small deflection is observed, and significantly at a very important particular point there is no deflection that is taking place we observe in the galvanometer, and that point is called as null point. So regarding this unknown EMF containing cell, we mark this point as null point, which is given by D dash. Now we will find the EMF of the unknown cell by using the formula. So with the help of that formula we will find out actually E standard cell divided by E unknown cell, that is ES divided by EX is equals to AD divided by AD dash. That means AD is the distance between the the null point to the A region, and AD dash is the very important null point and the A long wire AB distance, and it can be shown finally to calculate the EX. We will have AD dash divided by AD into ES. This is how we can calculate the EMF of the cell. Okay, now let us move on to the next important concept, that is galvanic cell. What is a galvanic cell? We will learn about it. Okay, let us go to the galvanic cell. Okay, coming to the galvanic cell, a galvanic cell is also known as a voltaic cell. So it is a cell in which chemical energy is converted into electrical energy through redox chemical reaction. So here galvanic cell is a cell which will converts the chemical energy into electrical energy, where in the cell the chemical energy is converted into electrical energy through the redox chemical reaction. And here the cell is consisting of two important half cells. One is anodic half cell and other one is the cathodic half cell. So at anodic half cell, oxidation process takes place, that is the loss of electrons takes place, and at a cathodic half cell, reduction process takes place, that means gaining of electrons takes place. And here you see there are some important chemical reactions that are taking place in the cell. At anode, a very important oxidation takes place, that is the loss of electrons. It is also called electronation. Here there are two electrodes we are taking. A zinc electrode is immersed into the electrolytic solution of zinc sulfate. If you look at the diagram, we can see clearly a zinc electrode is immersed in the electrolytic solution of zinc sulfate, and a copper electrode is immersed in the electrolytic solution of copper sulfate, and both the electrodes are connected to the external circuit called battery or voltmeter. And here the two electrolytic solutions are connected through salt bridge. And here in the case of this, zinc electrode undergoes oxidation and hence it will act as an anode, whereas copper undergoes the process of reduction and hence copper can act as cathode. Now let us go for the anodic half cell reaction and cathodic half cell reaction. At anodic half cell reaction, zinc which undergoes the loss of electrons and get converted into zinc ions, and the electrons will move to the external circuit through the battery and get collected at the surface of the copper electrode. Now the copper which undergoes the reduction, it gains those electrons and the copper ions present in the solution. So those ions will takes up the electrons or gain electrons and converted into copper metal. And here you see the chemical reactions are like this. Zn gives rise to Zn2 plus plus 2E minus, that is oxidation half cell reaction are taking place at anode, whereas Cu2 plus plus 2E minus gives rise to Cu, that is reduction half cell reaction which is taking place at cathode. And therefore the movement of electrons takes place from zinc to copper through an external circuit or external cell, voltmeter or battery. Now the overall net cell reaction is going to be Zn plus Cu2 plus gives rise to Zn2 plus plus Cu. And it is important for us to understand, the point is zinc alone acts as anode and copper acts as cathode, because zinc has more tendency to go into the solution as zinc ions rather than copper to enter into the solution as copper ions. That's why zinc always acts as anode, whereas copper can have more tendency to gain these electrons. Copper ions gains those electrons and get converted into copper. And you see the representation of the galvanic cell. The representation of the galvanic cell is Zn/Znso4 /CuSO4/Cu. What does this represent? A single slash or semicolon or comma represents phase boundary, whereas a double slash represents salt bridge. Okay, always we represent anodic part first with the help of metal, followed by the electrolytic solution, and in the case of cathodic part, first the electrolytic solution followed by the metal. That means the zinc sulfate, copper sulfate, and copper. And now this is related to the very important galvanic cell. And the galvanic cell generally it will have a net amount of voltage that is developed, or EMF that is produced by the galvanic cell is around 1.1 volt. How it is to be determined means, so we can determine it based on the very important so-called E cell chemical equation. E cell is equals to E cathode minus E anode, or else E right minus E left. You see, E cathode is the copper, therefore E copper sulfate copper minus E zinc/zinc sulfate. And the standard electrode potentials of zinc is minus 0.76 volts, and the standard electrode potential of the copper is plus 0.34 volts. Now you take the equation, and if you sort it out, then E cell is equals to 0.34 minus into minus 0.76. Therefore the minus and minus is, if you multiply, then it will becomes plus. So therefore 0.34 plus 0.76, and finally the answer is 1.10 volts. This is the voltage developed by the galvanic cell. Okay, let us go for the next important concept, that is we have what is the Nernst equation. So we have the next important concept that we have to learn here, and it is Nernst equation. What is Nernst equation means? Nernst equation is the theoretical relationship between electrode reaction and the corresponding cell EMF, and this is known as Nernst equation. So Nernst equation is generally used in the cases of some cells like galvanic cell. For example, consider a galvanic cell or a Daniell cell. So that is, you can take the example of a galvanic cell or a Daniell cell. Then we can try to calculate the E cell by using Nernst equation. So therefore you see the chemical reaction of A molecules of A reacting with the B molecules of B, and it gives rise to the products C molecules of C and plus byproduct D molecules of D. And here the small letters A, B, C and D, they represents the number of moles of the so-called reactants and the products that are formed, and even that at its equilibrium point. Now the Nernst equation for this above chemical reaction is written as E cell is equals to E naught cell minus RT by NF ln C to the power of C D to the power of D divided by A to the power of A and B to the power of B. It is the representation of the so-called equation, or else we can also convert it into logarithmic terms, that is E cell is equals to E naught minus 2.303 RT divided by NF log concentration of C to the power of C, concentration of D to the power of D, divided by the concentration of A to the power of A and the concentration of B to the power of B. And this is the cell, and if we substitute the constant values like gaseous constant, that is R value, that is we have gas constant value, and along with, if you substitute the temperature, that is 298 degrees Kelvin, and Faraday, that is 96,500 coulombs. So we can substitute all these important gas constant values, temperature and Faraday in the above equation. Then we will get finally the modified equation as E cell is equals to E naught minus 0.0592 or 91 divided by N log concentration of the products, that is C to the power of C and D to the power of D divided by the concentration of the reactants A to the power of A and B to the power of B. This is the equation, Nernst equation. And let us go further. Next important one, that is, we know very well. So we have some of the important applications to this so-called Nernst equation. So let us study those important applications. So coming to the applications, it can be mainly used to study the effect of electrolyte concentration on electrode potential. And the second important application is that here the pH of the given solution can be easily calculated from the measurement of EMF and Nernst equation. So we can measure the pH of the given solution, and even we can study the effect of electrolyte concentration on electrode potential. And coming to the third point, it can also be used for finding the valency of an ion or number of electrons that are involved in electrode reaction. That is the third important application. And coming to the Nernst equation of a Daniell cell, if we write the Daniell cell Nernst equation, then the Nernst equation of the Daniell cell is going to be somewhat very important. So example, so if you write the very important Nernst equation of Daniell cell, it is going to be E cell is equals to E naught minus 2.303 RT divided by NF log concentration of Zn2 plus divided by concentration of Cu2 plus. So this is the Nernst equation, and if we rewrite that, E cell is equals to E naught cell minus 0.0591 into log concentration of Zn2 plus divided by the concentration of Cu2 plus. This equation is going to be very important. And now let us move on to a very important electrochemical series. So what is an electrochemical series? Means an electrochemical series is the metals are there when these metals are arranged in the order of their increasing reduction potentials, or else in the order of their decreasing oxidation potentials, and which can be determined with respect to 1 molar solution of their ions, and they can be measured on the hydrogen scale along series or list, and the resulted series that is obtained is called as electrochemical series or else galvanic series. So simply we can say it is the so-called arrangement of the metals in the order of their increasing reduction potentials or decreasing of the oxidation potentials. Now you see, the higher a metal in the series means it is having the greater to undergo the process of oxidation, and it is having more tendency to get to be oxidized. And there are some important applications of this electrochemical series. So the main important application is we can determine the corrosive tendencies of metals and alloys, and it is very easy to understand the ease of oxidation and reduction of the metals. And the third one, the replacement tendency of the metals. These three are very important applications. And you see the list of these electrodes with their oxidation potentials and standard potentials and their nature. So the top important electrode is lithium, and it has a standard potential of plus 3.040 volts. And in the next categories like potassium with plus 2.924 and calcium with plus 2.870. And next we have the different types of metals, and in the middle we have hydrogen which has 0.000 volts. And on the least side we have fluoride which is having negative value, highest negative value, and even we know that value is going to be around -3, and chlorine is with -1. And the top, from the top to hydrogen, all positive values are there. These are called reducing agents, and from hydrogen and below there are negative values are there. These are called oxidizing agents. Okay, so this is about electrochemical series. So next we are going to learn about the types of electrodes. You see, there are various important types of electrodes are there. You see, the types of electrodes, first we need to understand what is the reference electrode. A reference electrode is an electrode with known electrode potential, and which is used to determine the electrode potential of unknown electrode, and by comparing it with a reference electrode, and that is called a very important reference electrode definition. The definition of electrode, reference electrode. Now hydrogen electrode is the primary reference electrode. We call it as a standard hydrogen electrode. There are again two types of reference electrodes, primary and secondary. Primary reference electrode is a standard hydrogen electrode with the electrode potential value of 0.00 volts, and this standard hydrogen electrode which can be used for many number of applications. So even though it is used for many number of applications, on the other side it has some disadvantages, because it is not suitable for some systems, like example redox system, like iron system, and even chromate ions like Cr2O7 2- and MnO4- like ions. This system is not applicable, like a standard hydrogen electrode is not suitable. Therefore there is a need of a new electrode, or the secondary reference electrode came into existence. And these secondary reference electrodes are with examples like saturated calomel electrode, glass electrode, quinhydrone electrode are the important, and even silver chloride electrode are the important examples of secondary reference electrodes. And coming to the very important primary reference electrode, that is standard hydrogen electrode. We have discussed or learned about this primary reference electrode. That is the very important primary reference electrode is a standard hydrogen electrode, and its reference electrode, its AMF is taken as, and it is fixed as 0. And you see the construction of the standard hydrogen electrode. It consists of a small platinum electrode coated with platinum black, immersed into a solution of 1 molar concentration of H+ ions maintained at a temperature of 25 degrees centigrade. And here the hydrogen gas at 1 atmosphere pressure is allowed or bubbled through the so-called over the platinum electrode, and it enters the glass hood, and the hydrogen gas at the platinum electrode passes into a solution forming H+ ions and electrons. Therefore this is given by the equation H2 gives rise to 2H++ 2E-, and you can see in the picture that is the diagrammatic representation of the standard hydrogen electrode. Okay, next we will be moving on to the a very important so-called calomel electrode, which is a secondary reference electrode. So calomel electrode, it consists of a glass tube having two side tube, and a small quantity of pure mercury is placed at the bottom of the vessel. So, and it is covered with a paste of mercurous chloride, that is Hz2Cl2 and Hz, and on the above there is a potassium chloride solution of known concentration which is filled through the side tube. And in order to maintain the potassium chloride inside the tube, we will allow, or we will fill the potassium chloride solution through the side tube. And you see that in the case of diagram as shown in the right hand side of the vessel. So you can see that on the right hand side there is a side tube that is used for the providing the maintaining the potassium chloride in the given tube, and the potassium chloride solution is filled in the left side tube, which helps to make a connection through a salt bridge with the other electrode, and which potential has to be determined. Now whatever the potential that we want to determine, that electrode has been connected to the saturated calomel electrode with the help of this connection through a salt bridge. And here a platinum wire which is sealed in a glass tube as shown in the diagram. So we have a contact with mercury. So there is a platinum wire, so which is having its contact with the mercury at the bottom. And when the cell is set up, it is immersed in the given solution. So this is the calomel electrode, and it is represented with the help of a very important representation, that is, we have three types of calomel electrodes. One is called normal calomel electrode, number 2 decinormal calomel electrode, and the number 3 we have saturated calomel electrode. So you take the normal calomel electrode with a 1 molar concentration. It is represented as 1 molar concentration containing calomel electrode with the electrode potential value of 0.28 volts, whereas decinormal calomel electrode with a 0.1 m concentration of KCl, that is with 0.333 volts, and the saturated calomel electrode which is having a electrode potential of 0.2422 volts. And so these are the three different types of calomel electrodes based on the concentration of potassium chloride. The saturated calomel electrode, decinormal calomel electrode, and normal calomel electrode came into existence. We can differentiate. Now the chemical reaction that is involved in this particular so-called calomel electrode is Hz2Cl2, that is mercurous chloride, gains 2 electrons and get converted into 2Hz plus 2Cl minus. And if we write the Nernst equation for this so-called chemical reaction of calomel electrode, then it is written as E cell is equals to E naught plus 0.0591 by N log Cl minus concentrations, Cl minus, or 1 divided by Cl minus ions concentration. Sorry, so it is a representation as E is equals to E naught plus 0.0591 by N log Cl minus ions concentration. Okay, it is the very important aspect. And if you rewrite, even it is written as E is equals to E naught minus 0.0591 by N log 1 divided by Cl minus ions concentration. Okay, so that is about the calomel electrode. Now we will be moving on to the second important type of electrode, that is a secondary reference electrode, which is useful for determining the pH of the given solution, and it is called glass electrode. So a glass electrode is one of the very important type of ion selective electrode. Specifically, it will recognize as the H plus ions, and that's why it is called as a glass electrode or else pH electrode. So it is made up of glass tube ended with a small glass bulb sensitive to protons. And this glass electrode is having a tube which has strong and thick walls, and the bulb is made as thin as possible. And inside the electrode it is usually filled with buffered solution of chlorides, in which silver wire is covered with silver chloride immersed. The pH of internal solution can be varied. So therefore, here in this electrode, the active part of the electrode is the glass bulb. The surface of the glass is protonated by the both internal and external solutions till equilibrium is achieved. And the both sides of the glass are changed by the absorbed protons. And this charge is responsible for potential difference. Therefore, a potential difference is developed at the surface of the glass membrane, and this glass membrane or glass bulb separates the two concentrations of the solutions. One is the internal solution and other one is a external solution. And therefore this potential is directly proportional to the pH of the solution on both the sides of the glass. The difference in its pHs of the solutions on both the sides of the glass. Okay, and the glass electrode especially works in the pH range of 1 to 12, and the glass electrode is represented as silver, silver chloride slash HCl with a 0.1 N concentration slash glass slash platinum, that is unknown. And here the silver chloride can act as an internal reference electrode. And now you can see it is the glass electrode and schematical diagram. You can see there is a very important thin walled membrane present at the bottom of this glass electrode, which is called glass bulb. On the top we have a silver wire which is coated with silver chloride. Inside there is a green colored solution that is present, which is called very important type of solution, dilute hydrochloric acid with 0.1 N concentration. Okay, this is about today's class. Hope you all understood. Thank you.